dealt with the metric system. So I'm going to review that really quick. So there's 5 steps in dimensional analysis, and we'll use these for every problem. So the first step is you're going to write down what you're given over 1. So we're going to say that I was asked for how many meters can I get from 2,500 kilometers? Actually, how many kilometers can I get from 2,500 meters? All right, and then, so what you're going to do is you're going to write down your given over 1. So if I have 2,500 meters, I put that over 1. Step 2, it says put given unit at the bottom of the next fence post. So I'm going to take, that's what I'm given. My next step every time is to make a second fence post, and then I'm going to put the meters on the bottom there. All right? And then the third step is the unit of what I want is going to go on top. So I've got my 2,500 meters over 1. I've got my second fence post. I already have what I'm getting rid of down here, and I want my unit of what I'm going to is going to be on top, which is kilometers. Right? Then I'm going to put my conversion factors in for the next step. So I know that whichever one's bigger with the metric system is going to get the 1. So there are 1,000 meters in 1 kilometer. So I put my conversion factors in, and the last step is you multiply the top and divide by the bottom. So in this case, there's a 1 on the top, so nothing. Divide by the 1,000, and my answer is going to be 2.5 kilometers. All right? So we're going to be using that today as we go through the mole. Does anybody have any questions on dimensional analysis? Okay, one of the teachers told me the other day that a lot of, she uses the Harry Potter example. So I'm not a Harry Potter guy, and I've never read any books or the movies, but where did Harry Potter live?
Hogwarts.
Where, though?
California.
No, where? Where was he put?
England.
No, like, he slept underneath he slept underneath the staircase, right? Right?
Yeah.
So, why did he get put there?
Because his parents are idiots.
Okay, because they were trying to get rid of him, right? So here's the deal. When you're trying to get rid of a unit, put it underneath the staircase or the thing, right? And then when you want to, what you want out in the open is going to be up top. So when you get rid of something, put it underneath the staircase and then put it up top. Like I said, I didn't see the movie, so hope that helps though if you saw the movie. All right, now today we're starting the mole. Now, you say, well, what is a mole? Besides having, I don't have any huge moles on my face or anything, or if you have a mole on your back, okay, you can get that taken off. But what is a mole? In science, it's the SI unit for counting, okay? So it's the number of units of something. Now, there was a really old scientist, and he is not a good-looking guy. So he had a lot of Friday nights to think about the mole, and Saturday nights to think about the mole. Okay, so and his name was Avogadro. And Avogadro found out that there is 6.02 times 10 to the 23rd atoms or molecules in 1 unit of anything. Okay, and that's this number right here. So you can see that is a huge number. Okay, I mean that is a lot of zeros. All right, so that's how many atoms we have in 1 mole of anything. All right, and so on the periodic table we're going to see that our masses, okay, are made up of, that's, if I have potassium, which is 39.0983, that's the average mass of 1 mole of potassium atoms. Okay, so it's not 1 atom of potassium has that mass, it's 1 mole, right? So, what we're going to be doing is we're going to have 3 conversion factors that we're going to use. The first one is a mole. So if we're converting from atoms to moles or from moles to atoms, we will always use Avogadro's number. So if I give you an example problem, if I say you have, 5.86 times 10 to the 25th atoms of calcium, and I want to know how many moles of calcium is that. Okay, you're going to use dimensional analysis just like you did in the thing I just showed you. So you have 5.86 times 10 to the 25th atoms of calcium, and you are going to put that on top. Remember, that is step 1. every time. Don't do it in your head. Don't, just try to scribble down paper. Keep it organized. Part of dimensional analysis and stoichiometry is staying organized. So that's what I'm given. So what is step 2 every time? The unit of what I start with goes where? We're getting rid of it, right? So throw it underneath the staircase. So it's atoms of calcium goes here. What is the unit of what I want? Step 3. Mole. So that goes on top. Step 4, fill in the conversion factor. What is the conversion factor between atoms and moles? We use Avogadro's number every time. So it's 6.02 times 10 to the 23rd atoms to 1 mole. All right, so you're going to divide the top by the bottom, right? Because you multiply any numbers on top, divide by any numbers on the bottom. All right, so when you do that, who's got a calculator? Someone's got a, All right, I'll run and get a calculator. All right. So when you're doing this, remember how to use our calculators and the exponent buttons. It's 5.86 exponent 25 divided by 6.02 exponent 23, right? And you get 97.342, blah, 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 okay? Now, how do you know how many numbers to keep in your answer? The number of sig figs in your starting thing, which in this case is 3, is how many I can keep in my answer. So I can keep 3 sig figs. So the answer is going to be 97.3 moles of calcium. All right, so that is how you would do a atoms to moles problem. Okay, well, what if I was doing a moles to atoms problem? Like, what if I said, how many atoms are produced from 2.87 moles of fluorine? Now I want to know how many atoms I'm going to get from that. Well, now what I'm given is the moles, right? So that goes on top. And I go to the second square, put the second fence post, put my given unit down. The unit that I want goes on top. Okay, I fill in my conversion factor at 6.02 times 10 to the 23rd atoms to 1 mole. Now I multiply the top instead of dividing it, right? Because the numbers are both on top. So 2.87 times 6.02 exponent 23, and you get 1.7, we're going to round that up to 3, times 10 to the 24th atoms of F2, which is fluorine. All right? So that would be how you would do a moles to atoms problem, and that is how you do an atoms to moles problem. All right, now the second part of this, okay, there's 3 parts today.